Welcome to the first of our two lectures on the use of statistical analysis in psychology. This lecture is based on the first learning target for topic 1.5 in the College Board course outline for AP Psychology. My name is Chris Gall, and I wrote this lecture. Today, we'll be reviewing some basic statistics. In many cases, you will have heard of these or used them during previous math or science classes. We'll also be talking a little bit about graphs and what various distributions of data can look like. So according to the College Board, by the end of this lecture, you should be able to apply basic statistical concepts, including interpreting and constructing graphs and calculating simple descriptive statistics. Basically, you should understand the appropriate terminology regarding basic statistical analysis for psychology, and you should be able to recognize common types of graphs that may result from various data. By the way, as you go, if the terms used here are not in your flashcards or vocabulary list, they should be. So central tendency is really just a way of asking the question, where is the middle of the data? There are three different ways to answer this question. Depending on the exact scenario you are measuring, one of them may be more valid than the others. Mean is what teenagers tend to call the average. It's measured by adding up all the data points and then dividing by the total number of data points. Median is what might be called a true middle. Half the data is above the median and half the data is below it. Mode is the most frequently occurring unit of data. Each has its strengths and weaknesses when it comes to measuring the middle of the data. Means and medians can be heavily influenced if there are outliers. If there are extremely high or extremely low data points, it can raise or lower those numbers artificially, making them seem to be something that they should not be. Modes can be tricky if there are several of different data points or if there are none of the same. It works best if there's a single data point that appears multiple times that closely correlate to the median or the mean. Pro tip, you do need to know how to determine each of these for a given data set. Variation is really just a way of saying how spread out is the data. And there are two ways that scientists in general and psychologists in particular use to measure the clustering of their data. The first is the range. It's a simple measure of the difference between the highest data point and the lowest data point. High ranges indicate that there is a very large difference between the highest and lowest data point, that they are very spread out. We'll give you a general idea of how spread out the data is, but again, that's something that could be influenced if there's an extreme high point or an extreme low point that function as outliers. The standard deviation is more exact. It tells you how closely the data cluster around the mean of the data set. Small standard deviations indicate a tight cluster. Large standard deviations indicate that data is very spread out around the mean. Pro tip, you should know how to calculate the range, but you do not need to be able to calculate the standard deviation. What you should be able to do, however, is figure out approximately how many standard deviations a data point is from the mean. Okay, and correlation coefficients are used during correlation studies. They show how strong a relationship is and what type of relationship it is. Correlation coefficients range from -1 to +1. The closer to 1, either positive or negative, the stronger the relationship. A correlation coefficient of +1 would show that there is a 100% correlation between the two variables, that as one rises, the other one also does, and that they rise at the same rate. A correlation coefficient of -1 would show that there is a 100% correlation between the variables, but instead of both rising, one rises and the other falls, again, at the same rate. In general, anything higher than about a 0.4, positive or negative, is typically considered to be a pretty strong correlation. So we're actually going to talk about 4 different types of frequency distributions. Here in part 1, they're the normal curve and a bimodal distribution. So a normal curve is also sometimes called a bell curve because if you made it 3D and cast it in bronze, then you could hang it from the top of Taco Bell. Kidding, mostly, at least about Taco Bell. There are a few key things you need to know about the bell curves. First of all, that the mean, the median, and the mode are all the same value. The second thing you should know is that approximately 67 to 68% of the data points fall within 1 standard deviation of the midpoint, and 95 are within 2 standard deviations. So when we talk about standard deviations, if you look at the graph there, that pink stripe in the middle, that's 1 standard deviation. Okay, so it's +1 or -1. Bimodal distributions are ones that have 2 modes, as the name says. When you see them drawn out, they have 2 humps, like in the drawing above. Other than the 2 modes, they have no special attributes that you need to worry about. Incidentally, if you did not do it, you should draw pictures of these 4 frequency distributions in your notes and not just write down the definitions. It'll help you to remember them and to recognize them later. So positive and negative skews are about which way the data lean when you sketch it out as a curve. It's counterintuitive, though, to think about, and that's because a negative skew leans to the right, which means that the values along the curve are getting larger along about both axes. Positive skew means that it leans to the left. In other words, the numbers along the curve are getting smaller as the hump leans to the left. Again, you should sketch a quick picture of these distributions in your notes. You need to be able to recognize them when you see them on graphs, and drawing them out will help you to do so. In addition to being able to recognize these distributions when you see them, you should also be able to do a quick sketch of them if needed to help you with questions on the AP exam. So we've reached the end of our lecture for this time. In order to tell if you understood everything you should have, you need to be sure to understand what measures of central tendency are and be able to name the three of them. You should understand the idea of variation, both range and standard deviation, what correlation coefficients are, and last but not least about some basic frequency distributions, normal, bimodal, positive skews, and negative skews. With the frequency distributions, you should also be able to sketch them out quickly and identify them on site. In other words, the drawings should be on your flashcards. If there's anything that you missed or that you are unsure of, you should rewatch all or part of the video. If you still have questions after that, feel free to bring them into class and I'll answer them there. Until then, so long and farewell.